Okay, in this video, we're talking about the difference between a degree angle measure and a radian angle measure. Okay, so we're going to be drawing these things. We're going to be figuring out their terminal sides. Okay, something to always remember is that we always start drawing an angle on the positive x-axis. Okay, so the angle always starts here, and then we rotate counterclockwise through a certain degree in order to make that angle. Okay, and then this is, of course, going to be the angle through which you have rotated. Okay, so we always start here on the positive x-axis, and then this is called your terminal side, the side that you end at. Okay, so positive angles go counterclockwise, and we will find that negative angles go clockwise. Okay, so that's what we're going to be doing today. So let's get some practice. I hope you have some paper so that you can make lots of little X's on here so that we can draw lots of angles. Okay, like I said, it starts on the positive x-axis and we go counterclockwise for positive angles. Okay, one way all the way around the circle is 360 degrees. So each one of these axes is, right, so this is 0 degrees, and then straight up is 90, the positive y-axis. The negative x-axis is 180. The negative y-axis is 270, and then back around to 360 degrees. Okay, and then we'll add 90 to make 450, and then add another 90 to make 540, and all the way around the circle. You keep going around and around and around. Okay, the more and more angles that we have. So we're going to draw an angle of 100 degrees, okay, and we're going to do our best to estimate this. So here's where we start, right, at the positive x along 0, and then we open up counterclockwise to a little bit past 90 degrees. Okay, I would say that looks like a good 100-degree angle. Okay, a little past 90, right? This is mostly estimation. We're doing our best. Now, the reference angle is the angle that we have to get to the next x-axis. Okay, so the reference angle goes back to the x-axis. So in this case, we need to go another 80 degrees in order to get back to the x-axis, right, to make it go exactly flat. So our reference angle in this case is going to be 80 degrees. Okay, because 180 minus 100 is 80. So the reference angle is the angle formed with your x-axis, not with your, given thing here. So we'll do some more of that. So 315 degrees. All right, so remember, 270 is here, and 360 is all the way around here. So 315 is 45 degrees less than 360, and it's also 45 degrees more than 270. So a 315 degree angle would come all the way around here, okay, and end up right there. Okay, that would be a 315 degree angle. Now the reference angle is going to be the angle that takes us back to the x-axis. So this is going to be your reference angle. Right, we have a right triangle here, and the reference angle in this case is going to be 360 minus 315, which looks like 45 degrees. Okay, so the reference angle takes us back to the x-axis. 195 degrees. All right, so let's go. This is 0. Right? This much is 180 to get exactly halfway. So 195 is a little bit more than 180. Okay, 195 degrees. So the reference angle that's going to take us back to the x-axis, in this case, is going to be the 195 minus the 180. Okay, because we want this angle right here. It's a little bit past 180, so we subtract, and we get a 15-degree reference angle. Okay, so 490. Okay, we know that all the way around the circle is 360. So there's 360 degrees. But if we do 490 minus 360, that will tell us how far past we have gone. Okay, so 490 minus 360 is 130. So we go another 130 degrees, which is somewhere in here. So there is our angle. Okay? So the reference angle, once again, is what takes us back to, sorry, it's got to be pink, takes us back to the x-axis. This angle in here. Okay, so we already said that this one's kind of a 130 degree angle. So a 490 is the same angle as a 130. Okay, those are called coterminal angles. So if we do 180 minus that 130, we have a reference angle of 50 degrees. Okay, that's what gets us back to the x-axis in this case. Okay, 820, our last example here. 360 plus 360 is 720. So we know that it's more than 2 times around the circle. So there's 360, there's 720. So let's do 820 minus 720, and that is 100 degrees. So just like the first angle, we're going to come around to about 100 degrees. So there is your angle of 820 degrees. So then our reference angle, once again, that takes us back to the x-axis, is going to be 180 minus the 100. Okay, because this blue angle is the same as a 100 degree angle. So this is also going to be 80 degrees. Okay, so our reference angle is what takes us back to your x-axis. Now, negative angles, okay, move clockwise around your imaginary circle. So we still start at positive 0, the positive x-axis at 0, but if we're going to do a negative 35 degrees, we are coming down this direction. Okay, this is a negative 35 degree angle. And our reference angle, the one that takes us back to the x-axis, in this case is going to be the exact same, only positive, 35 degrees. Okay, so negative 260, we start at the positive x-axis, and we know that this is negative 90 going straight down, and then negative 180, and then negative 270 is up here. So it's a little bit less than negative 270. Okay, so there's our negative 260 degree angle. Now the reference angle is what takes us back to this one. Right? What is this angle right here? Okay. So if this much is 10 degrees, right, 260 is 10 degrees shy of 270, and the vertical and the horizontal have to be 90 degrees, that means your reference angle is going to be 80. Okay, so there's lots of ways we can piece this out, right? In between every vertical and horizontal, every y-axis and x-axis is 90 degrees. So if we're 10 degrees shy of the 270, because this is 260, right? 270 minus 260 is 10. So if this much is 10 degrees, this much has to be 80. Right? So that's how we're going to do the rest of these, but I really want to jump down and do the radians before too long. So let's go look at the radians. Okay, now your radians are kind of neat. If you go to this Wikipedia, it's really kind of awesome. Okay, so what happens is we have a certain radius here. Okay, this is a certain radius. I don't know how long it is. Maybe it's 4 yards. I don't know. And if you take this radius length and you lay it along the outside of your circle, okay, you take the radius and you raise it as an arc length, the length of this arc. So this much is r. Okay, if you take a line and you draw it back down to your radius, this angle is 1 radian large. Okay, that's how we define a radian, is the angle measure where the arc length is the same as the radius. Okay, and it turns out that if you are watching that video, that there are exactly 3.14 lengths of that arc, right, that radius, that gets us all the way around to 180 degrees. In other words, there are exactly pi radians that get us from 0 to 180 degrees. Pi radians, which means if you go all the way around the circle, okay, we are looking at 6.28 radians, or 2 pi radians, because 3.14 is pi. Okay? And it's really neat that this happens with a circle. If you take the radius length and you lay it around the outside of your circle, there are exactly 6.28 radians around the outside, right? The circumference is 6.28 times the radius. That's the distance around the outside, the circumference of your circle. 6.28 times the radius. Okay, in other words, 2 pi times r. Okay, and that's the formula that we learned to find the circumference of a circle. Okay, there are 6.28 times as long as the radius, and that's pretty neat that that actually works. Okay, so if we want to figure out how much a radian is, we're going to take 180 and divide it by your denominator. Okay, because we are splitting 180 degrees into your denominator, right? That's pi all the way around. So a radian is going to be something in terms of pi, a fraction or a multiple of pi. Okay, and we're going to count the parts. It's really kind of nice, and we're going to be doing lots of division. So pi over 4. So what we're going to do is we're going to divide 180 into 4 parts. Okay, so here's our 180 degree line. We're going to divide it into 4 equal parts. Okay, so each one of these is 1/4 of a slice of pi. Okay, 1/4 of half the distance. So if we want a pi over 4 angle, that's going to be formed with your positive x-axis and 1/4 of this. So this angle here is pi over 4. Right? You divide your circle, your half circle, into 4 parts, and now we're just taking one of them for our angle. So the reference angle in this case is going to be the same as your given angle, because it's the one that takes us back to the x-axis. Okay, so in the first quadrant, your reference angle is the same as your given angle. All right, let's see if we can do this one. 5 pi over 8. So we're going to divide your half circle into 8 parts. Okay, so this is all done evenly, right? I'm making sure these are all even. So there's half and then there's 4. And then I divide these fourths into halves also. Okay, so I'm dividing my circle into 8 equal parts. I'm dividing my half circle into 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. And now I have to count 5 of them. Okay, so 1, 2, 3, 4, 5. This one here is the 5th section of pi over 8. So this angle right here is 5 pi over 8. Because it's 5 of 1/8. 5 1/8 sections. Okay, so our reference angle is the one that gets us back to your x-axis. Okay, so in other words, how many 8ths do we have left? We have 1, 2, 3 eighths. So 3 pi over 8 is going to be your reference angle. That's how many we need to get back to your x-axis. Okay, 4 pi over 3. Let's see, that's the next one. 4 pi over 3. So we're going to divide our half circle into thirds. So if we do that, these are all 60 degree angles, right? Because 180 divided by 3 is 60. But instead, we're going to go and divide the whole entire circle into sixths. So we have 6 pieces if it's pi over 3. Okay, and I want to draw 4 of them. So we start at the positive x-axis. And we go 1 pi, 2 pi, 3 pi, 4 pi's over 3. So this is your angle, 4 pi over 3. We divide half a circle into the denominator parts. And because it's more, right, 4 is bigger than 3, we have to divide the second half of our circle also. So if we're talking about the reference angle, that's the one that takes us back to the x-axis. So notice right now that would be 1 pi over 3 section. So pi over 3 is going to be the reference angle. That's how far past pi we have gone. We've gone 1/3 of a pi past 180. And it's going to take some getting used to, right? We don't normally use radian angles. You are much more familiar with degree angles. Your whole life has been done in degree angles for the most part, except for maybe a day or two in geometry. Okay, but we can do negative ones also. So here we have negative 3 pi over 4. So we're going to divide, right? Negative angles go down. So we're going to divide our 180, our half circle, into 4 parts, 4 equal parts. So each of these are about 45 degrees. Okay, and we're going to go 3 of them. So here's your positive 0. And now we're going to go 1, 2, 3. And this is the angle for negative 3 pi over 4. So we are dividing our half circle into as many as we have in the denominator. So we're dividing it into 4 pieces. So the reference angle here is the one that takes us back to the x-axis. So since we're dividing each of these into fourths, there is 1/4 pi over 4 would be how much we need to get back to the x-axis. Okay. So rather than negative pi over 4, the reference angle should always be positive. Okay, so this is a positive pi over 4. That's how much we have to continue going until we get to the next angle down here. Okay, the next x-axis. All right, 7 pi over 2. This one's going to be a little strange because we're going to divide 180 into 2 sections, so right down the middle. In other words, 90 degrees. Okay, so this is half, right? Half a pi. We're dividing our 180 into 2 sections. So this is 1 pi over 2. And now we need to count 7 of them. Okay, we count 7 sections. So we're going to go around the circle a couple of times. Okay, so here's 0. Now this is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Okay, so this is our negative 7 pi over 2 angle. Now, since this is exactly on a axis, right? This is exactly on the y-axis, there is going to be no reference angle. Right? Because a reference angle, as you see, is always made with a triangle. And since we're exactly on an axis, there is no triangle here, so there is no reference angle. Okay, so none in this case. Okay, our last wonderful angle is 17 pi over 6. So we're going to divide our half circle into 6 pieces. 6 pieces. Let's see. So let's go 1 here. So they're all going to be 30 degrees, by the way. 180 divided by 6 is 30 degrees. 1, 2, 3, 4, 5, 6. 6 pieces here. Now let's do the same with our bottom, every 30 degrees. Because 180 divided by 6 is 30. So as long as we can associate it, right, with something we already know, then we'll be okay. So we're going to count 17 of these. We've divided our half circle into 6 equal parts, which are all 30 degrees apart. Pi over 6 radians. So we're going to count 17 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17. 17 pi over 6 ends up right here, right after going all the way around the circle one time, and then we go around a little bit more. So there's a 17 pi over 6 angle. Now the reference angle is what takes us back to the x-axis. So if we notice, that's only one of these sixths. So we have a pi over 6 reference angle. Okay, it's one that gets us back to the x-axis. Okay, and then here are how we convert from a radian to a degree and from a degree to a radian. So if we have 45 degrees, that's our angle. We're going to multiply that by pi and divide it by 180 and reduce. Okay, so we're looking at reducing 45 and 180. So how many times does 45 go into 180? Okay, and that should be 4 times. So 45 and 180 reduces to 1 pi over 4. Okay, so we are reducing this, 45 and 180. What do they both divide by nicely? Okay, always reduce in terms of pi. So negative 240. we're going to multiply negative 240 by pi and divide it by 180. So what is the largest thing? I know that 20, right? 20 goes into both of these. Let's see if 40 goes into both of these. So if we do 240 divided by 40, okay, that's 6. And what's 180 divided by 40? 4.5. So that's no good. So let's go back to 20. 240 divided by 20 is 12. And 180 divided by 20 is 9. So right now it's 9 pi over 12, a much more manageable. Right now I know that these two both have a 3 in common. So I guess we could have divided both of these by 60. That would have been best. But a 3 in common here gives me a 4 pi over 3, and it has to be negative. Okay, so if we don't see the largest divisor straight off, which is 60, 240 divided by 60 is 4, 180 divided by 60 is 3. So we are reducing 240 pi over 180 to 4 pi over 3. Okay, and it's still negative. Now these next ones from radians to degrees is simply a multiplication problem. We times it by 180 and divide by pi. Okay, and the pi's automatically cancel out. So here we just have to use our calculator. 7 times 180 equals 1260 over 4. So divide it by 4. And I get 315 degrees. So 7 pi over 4 radians is equivalent to 315 degrees. Okay, so when we're going from a radian to a degree, we multiply by 180 and divide by pi. And the pi should always cancel out, as long as there's a pi to begin with. So 8 times 180 is 1440. So 1440 divided by 3 is negative 480 degrees. Okay, so our angle started off as negative, so our degree will be negative. Okay, if your angle starts as negative, then your answer will be negative also. It's going to be the same. So from a degree to a radian, you times by pi and divide by 180, but you're actually just reducing. Do all the reduction that we can to its lowest terms. And when you're going from a radian to a degree, you multiply by 180 and divide by pi. So the pi's cancel out and it's all done in your calculator. Okay, so I will see you on the tutoring session tomorrow if you need. Thank you for coming today.